Hello, everyone. My name is Elise Carmichael, and welcome to today's installment of the webinar about AI and the impact of the future of testing. So today we are hosting this webinar here at QA Symphony with our partner Qualitest. So you will meet Daniel shortly. So Daniel Geeter is working at Qualitest, and I'll let him introduce himself in a moment here. But he has a great interest and runs the AI practice at Qualitest. So we're very lucky to have him here today talking about artificial intelligence and machine learning. So just to do a little bit of housekeeping as we start this webinar, the audio you can get through your computer. Make sure you can hear. Of course, if I'm speaking this and you can't hear, that's not super helpful. You need Flash installed. Again, if you don't have it installed, you're probably having a hard time seeing this. But just check your internet connection. And you can resize these little widgets on your screen. And if you'd like to make the slide full screen, click the arrow icon on the top right of the presentation. So there is a Q&A section widget that you can enter questions throughout the webinar. We'll be answering questions at the end and potentially in the middle if there's something urgent. If you have any questions about the housekeeping rules or any other kinds of details, in and around AI and machine learning, we'll get to those at the end. If you have questions about QA Symphony or Qualitest, feel free to put those questions in the Q&A. So at the end of the webinar, you'll be asked to take a quick survey, so please provide some feedback if you can. And of course, visit our website, QASymphony.com or QualitestGroup.com for more information. So just a couple little announcements that we'd like to tell you about. So Quality Jam is a conference that QA Symphony hosts every year, and we are hosting a Quality Jam conference in London, October 18th. So we would love for you all to join, hear us talk about not just the QA Symphony products, but software testing in general. So one-day conference. And this is actually our second installment of this conference in London, and we have hosted this 3 times in Atlanta. So go ahead, log in, and get your tickets today. And one other note I wanted to make before I hand this over to Daniel is we have a conference with our newly partnered company or newly merged company called Tricentis. It's called Accelerate, and this conference will be in Vienna, October 9th and 10th. So if you haven't read about the news, we've recently announced that we've merged, QA Symphony has merged with Tricentis, and they're another wonderful software testing company. So please go ahead and check them out, check out the conference, and we'd love to see you there. So I'm just going to turn this over to Daniel. Maybe you can give us a little introduction about yourself, and we'll talk to you soon.
Okay, thanks very much, Elise. Hello and welcome. So as Elise introduced there, my name is Daniel. I'm a solutions architect for Qualitest Group. I've been working in software development, quality assurance, and most things in between for around about 9-10 years now, in varying capacities from development through testing, through automation, through non-functional testing. And one of the big drives in software at the moment is for more and more applications of artificial intelligence and machine learning. And we want to explore that a little bit today. Things about the implications of where artificial intelligence is going. We're going to talk a little bit about why artificial intelligence is so big at the moment, what this is going to bring to our testing process, but also what does it mean for us as test and quality professionals to be testing AI-enabled systems? Do we need to change our approaches, and how do we change them to make the most of these new tools that are available to us? We're going to wrap all of that up with a few conclusions and some food for thought, and then we'll go over some of your questions at the end. As Elise said, if you have questions as we go through, by all means drop them in the Q&A section, and we'll pick those up later. So before we begin, we'd just like to do a couple of little polls. This is the first one, just to get an understanding of who we've got in the audience here. So if you look at your widgets, you'll be able to fill in an answer to this poll question, and that would be extremely helpful for us to get a feel for what your current understanding of AI is. Just while you're doing that, we're going to talk about some of the current applications of AI. AI is huge. AI is reaching across software verticals in a way that no technology really has for a very long time now. If you can think of something that's currently conducting rules-based or functional software decision-making, you can almost certainly see ways that either AI is being used in it, in some of the more cutting-edge and bleeding-edge groups, or ways that AI could be used in it. And that can cover everything from network resource allocation, so choosing the path the packets take through networks, making sure that enough balances are turned on, through things like financial decision-making, credit scoring, loan assurance, how much loan to give somebody, through ad targeting. I think we've all seen context-driven adverts on our Facebook pages, on our Amazon pages, on our eBay pages, on our Twitter. Investment planning. How do you predict where investments should go in things like the stock market, which is a ever-changing beast? Can you start to use artificial means to predict the best place to put the money to make more return on investment? Maps and navigation. I think the smartphone is pretty much ubiquitous for most people now. Most of them have some form of maps and navigation. You know, the ways that Google Maps or Bing Maps or Apple Maps will take you where you want to be, going around roadblocks. A lot of that is powered by AI technologies. At the lower level, we can see routes for code optimization. How do you refine my existing software? How do you weed out things like inefficient code? Applications such as shopping suggestion, medical analysis. We're seeing a lot of research in things like identifying scans of one kind or another, whether they show particular patterns or markers of a certain illness based on artificial intelligence and pattern recognition. We've also got areas such as malware detection, smart cards, resource planning. Internet of Things is enabling us to have things like smart vision, those wonderful filters you see turning up on all of the image sharing applications where you can change the way your face looks or try a different hat on, for instance. An awful lot of these things are powered by AI in one form or another, and these applications are just going to grow. So a lot of these either are using AI now or they have the potential to use AI very, very quickly. And as a testing industry, we need to keep pace with this. So looking at the poll results, we've got a reasonable mix here. So we don't have anyone that's worked extensively with AI. We've got a few people that have come across it. And we've got a few people that are after an introductory phase, I think, here. So that being the case, we'll talk a little bit more about some of the things that might appeal there. So how is software development changing? At the moment, we're seeing a few disruptive technologies have come into the market, and they are starting to advance us in different ways. Things like cognitive analytics, the cloud, the Internet of Things, deep learning, big data. These are all areas that have received huge interest in the last handful of years, and they're driving huge transformations in the way that we actually build our software. They're pushing us for more and more automation, more and more doing the legwork for us. They're also pushing us for more and more personalization. They're driving up the convenience aspects of how we handle a lot of our computation, whether that's something as arbitrary as asking your phone to automatically set you a reminder to pick up some bread and milk on the way home, or something as advanced as having a completely automated resilience pipeline in a disaster recovery scenario. We're seeing more and more of these technologies pushing that. Now, I don't want to dwell too much on all of these things because there's webinars in their own for each of them, but what I do want to take a look at is deep learning and how and why deep learning, machine learning, and AI is such a thing for us at the minute. So, to start up with why AI has risen as a factor. AI as a concept isn't actually new. We've been talking about AI and machine learning since the 1940s. One of the first thought people to be behind the term was actually Alan Turing. Many of the algorithms we see in use in present AIs and machine learning systems have been around for years. They've been theoretically discussed backwards and forwards by academic circles for a very long time. But they haven't really made it out of an academic and a classroom setting. The reason for that has been in no small part that artificial intelligent machine learning systems require an awful lot of data, computational time to train up and build. It's only really with the advent of cloud computation where we've been able to scale out processing to huge and unexpected new levels, and the capture of big data, the retention of data around everything from how fast did you go convert a click-through on this website to whether or not you bought things of this kind, that kind before. The pooling of all of that, creation of these data lakes and the ability to process large volumes of data has got us to the point where we can start taking these AI paradigms out of the classroom or the lab and applying them in the field. For some numbers on what this means, the last few years we're seeing explosions of this processing. In the United States alone, there's been a 14 times increase in the number of active US AI startups since 2000. And obviously where the businesses go, the money goes. The venture capitalism investment into the AI startups has increased sixfold in that time. There's a huge market surge into the development and powering of AI. You can see this trend is similar in Canada, the UK, mainland Europe, but it's most strongest and most pronounced in America at present, but that doesn't have to stay that way. Before we continue a little bit more, we also want to try and get a feel for how much exposure to AI in test you've had. So you'll see we've got another poll here. It would be extremely helpful if you guys could fill it in if you've got any exposure to AI in test processes at present. And while you do that, we're just going to talk about what AI-enabled testing means. So making AI work for testing. Current AIs are very, very good at finding data. They thrive on it. The right amount and the right type of data is the lifeblood for AI systems. And when we think about what this means for us, if we can start to think about ways that we can break our everyday test and quality processes down into discrete data-driven constructs, we can start to think about ways that an AI can enable and empower them. One of the starting points for this is the prevalence of the powerful test defect application lifecycle managers, using the things like HP's ALM or Octane or Jira, TestRail, Rally, Qtest. These tools have already started us breaking our testing down into its constituent parts. We're already starting to treat requirement test cases traceability. I mean, we've known for a long time as software quality professionals that all these things are separate, but we're being forced to store them discreetly. A lot of these tools come with APIs and SDKs that let us get to this data, and we can start to latch into these component parts to build and train AI models off the data of our testing. Like many things, though, this is a bit of a two-edged sword. The AI will only be as good as the data it learns from. If the data is not accurate, the AI is unlikely to be reliable. There are certain paradigms where you can start thinking about extrapolation, but generally we need AIs to work off good data to give us a reliable model that we can have confidence in. For what this means in real business terms, before we can start to use an AI on our testing process, we need to make sure that everyone in the organization thinks and talks about testing the same way. We need to know that if one team talks about requirements, another team talks about user stories, are they talking about two fundamentally different things, or is it just that the business treats those two areas as different names for the same thing? We need to pick one and stick with it, much like the ideas BDD brought, whereby if we use the given when then syntax for our feature files, everyone talks about the same thing, we can automate the same way. AI needs the same thing. If we codify our tests in the same way, if we have well-maintained test tooling, test processes, well-documented, well-known, and actively maintained, it becomes easier to make AIs that can deal with a lot of this heavy lifting and decision-making on testing for us. The second catch is that AIs are quite empiric. At present, we don't have what we would refer to as a general AI, an AI that is capable of doing everything you would say any other intelligent creature is capable of doing. AIs are very, very good at solving a very specific problem, a problem such as is this item of type A, B, or C based on what I've seen before? Can I find out what the likely context of this paragraph of text is based on things that are mentioned? Quite specific problems. And within testing, we can see the same sort of things. We can find AIs, or we can start to see how we can use AIs for certain parts of our testing. But at the moment, there is no AI that is just generally, it's a good tester. We would look to use AIs for certain challenges that face testing. We'll come back to that conversation point in just a second. Before we do that, though, looks like we've got a lot of people that don't have that much exposure to AI here. And we've got some people that are just sort of starting to dip a toe and get a feel for what AI-enabled testing looks like. So bear in mind what we were saying, that we were thinking about the very heavy data-oriented parts of testing where we could start to use an AI. You can start to think about how you might have an ideal world for what truly AI-enabled testing might look like. So, for instance, we can start to use an AI to take some of the lifting out of our test planning. For instance, details of what are the requirements, what are the changes that have gone into this release. If this stuff is codified and I've got similarly very strong traceability through test cases and coverage is known, I can use an AI to quite happily start to prioritize my testing for me. If I'm covering new areas, I can start to use an AI to look at representative data sets we've had before. For instance, let's say we want to roll a new page on our shopping cart. We did something very similar last year. We used this test data, this test data, this test data in conjunction with these test cases. We can use an AI to start to think about some of the test design for us. If we look at codify our test cases themselves in database constructs, so for instance, if you think about things like model-based testing, there are tools out there at the moment that will already start to look at pulling the details of that model together and work out execution flows and paths that need to be taken through the model to ensure coverage. We can start to use AIs to bootstrap and springboard some of our environment readiness. So for instance, we can use the concepts that we use around resource and environment planning to make sure that we have environments being spun up that contain the right data. We can make sure that we have environments of the right type set up. So for instance, we can use the same AIs during production for things like intelligent DR. We can use that to clone into test the equivalent of the AI. We can start to think about, can I use a problem-solving scheduling AI to optimize my environment availability? I've only got 3 test environments. I've got 4 teams that need them. Can we use an AI to intelligently quantify who should and should not have the environment at certain times? When we think about the hands-on text execution side, what about exploratory testing? What about using an AI to start to explore different parts of the application? Or what about using an AI to take care of some of the lifting of fuzzing for us, going back to that thing about test data definition and consolidating test data? It's easy to see how you could, keeping track of all of the test data you've run before, past failures, an AI could be used to find a pattern of representative test data that across 90% of websites isn't good, or across common projects is often an issue for this organization. Maybe that's something as arbitrary as double byte encoded characters, or maybe it's certain types of boundary analysis. We can also start to think about how we would use AIs to test things that are more geared towards users at present. An example would be something like Applitools Eyes, where machine vision is used to understand whether or not one page of an application looks the same as another page of an application. We can see more avenues for advancement of AIs in user experience. Lastly, we can use test reporting. Again, AIs thrive on data. If we pull all of this stuff back together, we can use AIs to give us a very, very clear, healthy understanding of how our testing is done. We can use an AI to pull not just what was the pass-fail ratio, not what was the red-green of the build, but we can use an AI to think about other things. Did the squeezing of 10 extra story points into this cycle have a longer-term effect on the quality of the product 3 weeks down the line? We can start to use an AI to quantify that for us. We can latch into something like a resource planning. I know that I've got 4 testers that are due a holiday soon. How will I deal with that? Will I need to quantitatively cut back on the story points I'm going through, or is there enough bandwidth in other teams that we can latch across? There is no one silver bullet that is going to enable all of these things. It'd be great if we had one system that could do everything we discussed on the previous slide and more. That's not going to happen. But we can see places where we can use AI technologies to give us little bits and pieces of that journey. We can see where you could bring in an AI that will work solely on prioritization. We can see where you could bring in an AI that might look solely at consolidating my data. What's the most common test data that's used? We can use AIs for things like, can I deprecate this test? It doesn't prove any value to me anymore. Each of these changes is going to come from small incremental tweaks. and adaptations. We don't have a silver bullet that can big bang everything into a fully AI-enabled process. In each stage, we're going to have to work and build on what we've done in previous stages to build up and go forwards. We also need to make these improvements into our process slowly and in isolation. I think we're all familiar with this concept. We've seen it in organizations as we move towards agile, as we move towards more automation, as we move through shift left, shift right, depending on whereabouts on the DevOps spectrum you might sit. Small, controlled changes will help us do all of this. We need to take our lessons learned, and we need to build the strategy that will enable more AI use in our testing. When this is done, the next logical question is, well, what will my testers be doing? By focusing AIs on taking some of the meat out of this test process, we can start to focus as testers on higher valued aspects of testing, the things that machines can't do. So, for instance, is the product as feature complete as it could be? That level of creativity and insight isn't really common in AIs. They're not capable of that kind of innovative thinking at the moment, but we as users are. We know that, generally speaking, I have a good or a bad feel for this version of the application. Does the big picture hang together right with what my organization as a whole has as a mission statement, where they want to take their software? These kind of things you can't codify. You can't drive these down to the data-driven level that we would use for an AI, but you can, as a tester, then focus on these things. What will AI-enabled testing actually give us as testers? These technologies are going to be a huge boost, but we also need to be aware of what AI cannot do. Much like automation could execute tests faster than manual testers, AIs will process data faster than manual testers. They will spot patterns in test results that we don't see or that we don't have time to look for. Test AI is, however, not likely to find a brand new problem, not in a founding problem it's already looking for. Going back to that thing, does it generally feel right for the way my organization likes to build software? And AI is not going to give you that. We can use AIs to strengthen the reliability, the repeatability of our testing, giving us more information, which tests need to run, which ones don't. Give me the insights, what actually is the maintenance deficit looking like on my automation? Can we start to think predictively, is this build likely to fail based on a list of known changes that have happened in the past? We can expect improvements in the efficiency of our testing process. Using things like automated resource allocation, we can take some of the pain of environment contention out, for instance. We can use AIs to work out dynamically how do you scale up and down the need within your testing environments. With AI enabling our testers, as testers, we can step back from some of the mundane things. Much like with automation before it, we could step away from some of the tedious scripted exercises. We could offload this onto the AI. We can do the same thing here. We can start to take away some of the pain points of test management reporting and put that onto the AI. We can start to take away some of the pinch points on exactly how many combinations do I need to work my way through this form. We can start to use AIs for this sort of stuff, giving us the freedom to look at newer features, newer approaches, and things that AIs are not well suited to solve. In short, AI-enabled testing is going to give us an ability to step away from QA ninjas and mavens, the one guy in the test team who's the only one who knows how the product works, is the only one who knows whether or not this is like to have a knock-on effect on that. And it's going to start to give us informed and qualified decisions. It's going to let us have a bigger data-driven element for our testing and let us make better decisions on the quality process as a whole. So that's one side of the coin. We've talked there a little bit about what is AI going to do for my testing. But there is another side to it, which is, what about customers shipping AI-enabled products? Do we need to give them any special consideration when we test them? And the answer is yes. Historically, all of our systems have taken an input, applied some rules to it, and they've given an output. For instance, the little diagram we got on the top left there, you can think of a machine which is just designed to, given the input of 2 and 2, give me 4. In the old school, we would say the input A is 2, input B is 2, write a rule that adds those two numbers together. The same inputs should always give you the same output. This is what we refer to as a deterministic system. 2 plus 2 is always 4. There's no whys or wherefores about it. It's easy to test these systems. We know what the ins and outs are going to look like. Machine learning doesn't give us this. the majority of machine learning paradigms are given a sample input, a sample output, and they're told to work out the rules for themselves. And this can be many samples of inputs. We're talking tens of thousands. The more data you give an AI, the better the AI becomes trained, but it also means that there's more combinations of what it can go through. For an example, there's a few data sets mentioned here that are currently very popular in training various AIs that are out and about, people are experimenting with. There's a data set called the Stanford Question Answering data set. This is used to train AIs for knowledge evaluation questions and answers. In other words, typing into a system a question that you want to find out or asking it a question via speech recognition. And it will try and find you a relevant answer. In the freely available training set, there are 100,000 pairs of questions and answers. In the Stanford Natural Language Interface corpus, so this is a training data set that is used to teach AIs how to interpret written text better. There are 570,000 sentences. There's a Wikidata project, which is pulling together data associations that back the Wikipedia projects. There are 50,000 items in there alone, and it's growing. Google have probably the single biggest image training and classification set that's freely available. And this is designed to teach images that are designed in computer vision. So in other words, machines that can recognize objects that are in a picture that is presented to them. There are 9 million images across 6,000 categories in that image set. Given the size of the training data that is available for these things and how many different ways we can work through, the same outputs in these systems can come up with varying outputs. The same inputs can come up with varying outputs. So for instance, if we go back to our example of the machine, as opposed to saying the inputs are A, B, and the rule, we're saying the inputs are A, B, and the output is C. We don't actually know whether the rule was plus, whether it was times, whether it was squared, whether it was to the power and take a bit away. We can't determine that. The rules to AIs are generally gray, if not black box. The way that we need to think about testing these things, therefore, is re-evaluating the way we test non-determinism. How do we get enough inputs to test the system? Testing an AI in and of itself is not a threat to us. We just need to re-evaluate our way. But we test. We need to educate ourselves around non-determinism. Historically, testers have always steered away from non-determinism. It's a pain in the neck. With the terms of automation, it leads to flickering results and unreliable build, and nobody trusts the CI system anymore. With regard to choosing your test data, it's very difficult to cover all those bases. AIs are almost inherently non-deterministic in many applications because they don't have A plus B is C. It can vary. So now we need to work out how we deal with that. There are certain lessons learned. So for a while now, where we've had to think about testing things like random number generation or random sequences, we've worked by testing representative samples of the data. With AI, we're going to have to start to think about the same sort of thing. How do you cover enough conditions that you have a good general feel for the AI? I also think that what's going to happen is that not only do we need to think about old AIs, we also need to think about new AIs. We also need to think about what about old products where we add AI, where AI is enabling part of an existing product or replacing it. Will our existing regression cases cover it? We know that we might not have enough samples of data, therefore, so do we cover enough of those cases to be sure that regression isn't introduced? How do we make sure that we're not introducing a regression on an existing product by changing it from an old rule-based system to a new AI-based system? What about situations where AI is a part of a larger process? So, for instance, if my system is still developed to be standard functional, but I now introduce a DR pattern that is AI-based, how do I cover enough conditions in my DR testing to make sure that I've seen enough of the fallovers on the AI? What about things like chaos engineering, where we can use AIs to turn off parts of the test environment? An example for this is the Netflix Simian army, whereby we can use AI to switch off certain nodes to ensure the environment microservices all hold up in isolation. To deal with the ways that AI is going to change testing and how we need to change our mindset as testers, there's going to need to be a very tight tie-in with the developers and with the data scientists that are building the AIs. I think this is going to get to the point where, much like we saw the rise of the develop, engineer, and test as automation grew more popular, we will see the rise of a data scientist in test for AI systems as AI grows across the board and it reaches into more and more markets. There may even be a fourth amigo starting to turn up in the agile planning team. We've got the data scientist, and we've got the programmer, and we've got the test lead, and we've got the product owner. AI is going to change everything in a fundamental way, but that doesn't mean that we can't go with the change. Okay. So where does this all actually get us? AIs are here and they're here to stay. We've seen that they're reaching across verticals. They're already changing the way we test. There are tools on the market starting to use AI, and we've got customers saying to us, I have an AI-enabled system, how do we test this? The share of jobs relying on AI skills in the US alone has grown 4.5 times in the last 5 years. That's a huge growth. We can work with AI capabilities to bootstrap our testing. We can start to use AIs to think differently about how we handle our test data, how we handle our test processes. But AI technologies are a gift of fire. At the moment, the skills relied to build and test AI systems. The building relies mostly with the data scientists and development teams. The testing of them, AIs introduce test paradigms we've always tried to avoid. We can't see what's going on, and it's very hard to unpick the rules of an established AI to understand what it does. We're going to need to understand that when we roll an AI, we don't introduce new regressions. There's a prediction that by 2020, 50% of new data transformation flows are going to integrate ML algorithms, and they're going to start getting it wrong. As quality engineers and quality assurance professionals, we need to be aware of this. We need to know what we're starting to look for. We've always shied away from this kind of non-deterministic testing. We don't really have the methods required to deal with it because we've always educated ourselves as testers and developers that it's a bad thing to have in the system. But we need to deal with it now, and new methods are going to need to rise. And it may well be that testing is going to get a few of these things wrong before it gets them right. That's okay. It's a learning journey that we have to go on. The skills required to test AI are more common with data scientists. But I think what we're going to see is a new path that's going to form for the QA professional. We're not just going to have the manual functional QA, the performance engineer, the pen tester, the automation engineer. We're going to start to see the data scientist and test rise up among this as well. Okay. So I think it's time to take a look at some of the questions.
Great. So we've actually gotten a number of questions here, and I think the most fun one that I wanted to start with here is Venkat asks, is an AI system, quote unquote, allowed to learn things which are not expected by its human creators? Okay, so if I'm understanding that question correctly, the idea is, what if the AI continues to change its rules in the field? And I think, yes, it makes it harder to test, but I don't see a problem with it. For an example, let's consider a shopping recommendation system. If I build and train an AI on the historic sales figures for my organization for the last 5 years, let's say I've got the data that goes back far enough, and I can see what people tend to trend and buy, I don't want the AI to stop learning the moment I send it live. I want the AI to continue to learn. I need it to be aware of new trends, of new patterns. With things like a more abstract concept, things like market prediction, there may be factors in predicting something like a market that a standard AI just going on whether the FTSE rose or fell at all in the last 6 months. You may find that market forces are governed by things other than that. I think, yes, the AI will need to learn outside of its original training data, but I do think we need to be aware of what it's learning. I don't think it's necessarily the problem that the AI will continue to learn. I think for advanced uses, the AIs are going to have to learn, but we need to make sure we are aware of where it's learning and what it's learning, making sure that box stays at the very least grey to us rather than becoming a complete black box and we don't really know anything about where the AI takes its feeds from. Great. we have a couple of questions about tooling. So Lija and Nitish both ask, sorry, my questions jumped, but Lija asked about what tools, or are there any tools already available which can help take care of the options you had mentioned for tracking testing?
Sure. So the short answer is yes. There are organizations that are working on AI empowering their testing, but it depends on where you're looking. So there are tools out there that will use AI to start to build tests. There are tools out there that will use AI to start to manage tests, and there are tools out there that will use AI to look at reporting and prioritizing testing. It's hard to give you a specific list without knowing a little bit more about which particular ones you're interested in, but feel free to send a reach out and we'll try and come up with some specific ones for you.
Great. So we have a couple more questions here. So Alan asks and says that this was a great introduction to artificial intelligence, but where should a QA tester or developer team start with AI? You know, how can we start introducing AI? What tools, libraries? And I know you had said something about some of the most important things you can do even before you get started is with the training data and making sure that you have good data in your system. But could you elaborate on that?
Yeah, so I think there's two things to consider. The first of which is, what are you trying to use an AI to do? Just to say, I want the AI to make my testing better. That's great, but it's pretty nebulous. If you're looking for an AI to prioritize test cases versus an AI to generate tests versus an AI to just give you a general feel for whether or not my project's going right, you need to look at very different sets of data for each of those things. The first thing you need to work out is, what do you want AI to give you? What is your specific problem that you're trying to solve? And it needs to be not necessarily a small problem, but a well-defined problem. And you need to have enough data to build it. So let's say I want an AI that can identify patterns in my build failures. You would need to start to think about things like, well, where does it find that out? How do I constitute a build failure? Well, that's okay. I've got the Jenkins red-green status. Okay. What goes into making that build important and a pass or a fail? Is it the quality? Is it the details of the changes that went in? Do we have the configuration notes for environmental changes that went in? Do we know what the code changes were? Do we know what unit test changes went in? It's identifying these sorts of things, and then you need to codify the input data, the output data. The output data in this situation is pretty straightforward. It either passed or failed to build. But the input data needs to be a structure of all the different types of data. This is where the data scientists come in. So the first step to AI enabling testing is you use a data scientist to work out what the data of the problem is. Okay? Then once you've got the data, you need to understand which models you want to use to learn. So there's 4 phases. The first of which is identify the problem you want to solve. It doesn't need to be a small problem, but it needs to be well defined. The second one is identify the data that will feed that problem and solution definition. The third one is identify the learning paradigm you want to do it. There are different types of machine learning for different types of AI problem. Broadly speaking, they come into supervised and unsupervised. Supervised, we're expecting an AI to look for a pattern we know we're looking for. Unsupervised, we're looking for something we haven't seen before. We're looking for a new trend, a new insight into our data. Then you need to train the model and check it's doing the right thing. It's no one step. It's a process. And it's not an overnight thing. It's going to take time, the same way adopting any new tool or methodology takes time.
Great. We have another question about, what exactly falls under the AI umbrella? Is it automation for data creation or verification, so some kind of automation checking? Would that be considered AI, or is it really just things that learn by experience?
No. So the question there, if I understand it, is the definition between AI and machine learning. In the present market, these two terms are used interchangeably. That's actually not quite correct. So artificial intelligence is the exhibiting of intelligent behavior by a false system. And that could well be things like your data creation. Your data creation doesn't need to be intelligent in that regard, but it needs to be something that you would usually attribute to another intelligent life form. examples of AI could also include, I mean, we talked quite a lot about machine learning AIs here, but there are things, for instance, you can see AIs that perform intelligent problem solving based on the behavior of ant colonies or based on the behavior of flocks of birds in flight. AIs is a very broad area. Machine learning is a more specific discipline. Machine learning does relate to a machine that improves based upon repeated training and experience. And whether that's the training that it does in the first instance, so given a large set of data, go and find the rules that make this work, whether that's continued development along the lines of what if it continues to grow in production, is kind of irrelevant. They've all come under the banner of machine learning. The other term that you hear quite a lot at the moment is deep learning. Deep learning systems are a particular type of machine learning system. Okay?
Great. So we have, I think this is a great question. Can AI be considered a privacy risk? Learning and assessing user-based data. Do you consider it a privacy risk potentially by learning more about how people are using your system?
That is a great question, and I'm not a disclaimer. I'm not a privacy guru, but I think that will depend on what you've agreed to use users' data for, and what your users have agreed to allow that data to be used for. Is there a privacy risk to someone else cracking the AI and extracting the data? That would depend on where the AI stores the data and how accessible that data is, what the outputs are. For instance, if your AI gives a specific output that would include user-specific data, then yeah, there are privacy considerations. If your AI's output is find me a person that is closest to this, then that's a privacy concern. If it's something like an anonymized trend analysis, then I think it would depend more on what your users have agreed to the data being used for. But it's like any system that uses any kind of user data. There's always a risk there at some point, but it's quantifying it and gauging it is a very specific thing. It will be quite subjective to that one system.
Great. So I think we'll just have a couple more questions. We have a few more slides and a poll that I would love to get to. But I have one question that's sort of near and dear to my heart, which is, at what point do you feel we'll be able to trust artificial intelligence or machine learning enough so that we stop, with manual testing and automated testing? Or, at what point do we feel confident, or how do we know when we feel confident?
Yeah, I think that question comes down to historically the same way you learn to trust your automation. For a while, I don't think it's going to be day two after you've rolled your AI out. I don't think it can be. AIs are like any system. They're like any paradigm. We need the time to evaluate, to build that confidence. For a lot of it, some of it is going to be, in the first instance, I want to contrast what the AI is doing. Where we've got that example that AI is learning something in production, how do I check it's learning the right thing? How do I check it hasn't completely blown out of water what it was designed to do? We need to supervise. We need to check that the inputs and the outputs still make sense by effectively co-watching what the AI does. For an example, more specifically, Google recently released an announcement that one of their data centers now has a large parts of its HVAC controlled by an AI, but it has taken them years of watching what the AI wanted to do before they had that confidence. There is no hard and fast answer. I can't say that, you only need to watch it for 2 weeks or you only need to watch it for 2 months. It's not like that. It will depend on your application, the quality of the data, and just how far off the mark the AI is or is not with every iteration, with every bit of learning. I do think the time does come where you can at least minimize the input of the manual tester to maybe just sanity checking the AI's results, whether it's a planning result, whether it's a data result, whether it's a case gen result. But I don't think there's going to be a hard and fast rule. I think it will depend on the project.
Mm-hmm. Great. So we have a couple of questions about kind of how do we get started? And I think we might need more information about this, as why and what you're trying to do with AI and machine learning in the first place. But a couple of people have asked, what kind of infrastructure investment are we looking at to introduce AI and machine learning at, I assume, our companies? I don't know if this is in terms of testing or in general in the product.
Okay, so If you're just interested in a learning exercise to build and play with AI, there are toolkits available. You can just get them up and running on a standard laptop. If you want to actually build a production-ready AI, you're looking at more specific infrastructure. Depending on the type of AI you want, depends on what exactly you get. You are seeing the rise of provision through guys like AWS and Azure, where they're offering machine learning platforms in the cloud. At the very top end of the market, you've got guys like NVIDIA who build servers that are just designed for machine learning training on. It really depends on what you're trying to use the AI to do. Rolling AI into your product, there are toolkits arising that will let you effectively put a trained AI model into an application. But I foresee that more AIs will live effectively on servers and cloud provisioning, and you will have some sort of client application that will talk to them. I don't think that will be the exclusive case, but I think it will be the more common case.
Great. I think we'll just take maybe 2 more questions. So this one is from Joseph. He says, can you describe an example which would use an unsupervised learning system regarding testing a system? And what would the outcome look like, and how would you know it was correct?
Okay, so unsupervised learning systems are designed to find patterns in data we do not know is there. I think the best example that I've discussed for that would be, is there a specific set of inputs that I haven't yet realized are particularly effective at finding a problem in my system? So if I were able to replay the test data that I've used over the years, if I have been being a very conscientious quality engineer and I have captured my test inputs at varying times, or I've captured the logs if I've been generating synthetic test data, and I can see the defect patterns that arose, can I start to find particular combinations of inputs that just find more problems? Maybe it's a less common name, maybe, like I said, it's a double byte encoded character. The output, in that case, would be, this is the test data that should find you a good density of defects. How would you evaluate that that in and of itself was good? Try it with some of your standard ones, run them side by side and see what you get. In that case, the AI is offering you a decision. It's not executing the testing for you. It's just saying, as an information system, I think you should look at this.
Great. This question just came in, which I think is very interesting, is how can you protect too much learning, like the AI cursing chatbot? Or how would you protect or limit the learning of it?
So that's actually 2 separate questions. How do you deal with too much learning? That is a part of the building and training of the model. When we build and train AIs, we tend to partition our data sets into how much is used for training and how much is used for benchmarking that the AI is ready to go into live. And what it really comes down to is, what are the accuracy thresholds, and at what point did the AI start outperforming on certain sets of data and underperforming on another? In other words, at what point did the AI start to learn noise? With something like an unsupervised AI, which was the case with the cursing chatbot, that was supervised in the wild. And when people felt that the chatbot was getting a little bit potty-mouthed, it was pulled from production. But within an internal system, within a supervised system, there are effectively mathematical rules and heuristics for AI training around when do you feel you've trained enough? At what point does the detection thresholds get better or worse? And do you say this is now good enough? Unsupervised learning, it's manual checkpoints, the same as how do you know when a production system is getting saturated? You watch it.
Great. All right, last question. So one of my favorite things that I've heard you talk about is the Netflix Chaos Army. So this is the thing that goes through production systems and just takes down different parts of the system and makes sure that it still works and the failovers work correctly. Do you think this is going to become a standard at all large enterprises that need high uptime?
I'd like to think it will, yeah. I think as a quality concept, chaos engineering is a very useful tool, particularly where you've got huge distributed systems and you've got pure microservices architectures where you do need to know that you have high resilience, low latency if one service fails. I think it needs to be handled very, very carefully because there is that element of chaos to it. We'd all like to say we live in a world where, of course, our systems are 100% reliant. If I turn off one microservice, no, the rest of it won't catastrophically fail. I do believe that organizations pushing DevOps and distributed computing heavily, microservices and distributed computing heavily, and with a view to DevOps where you need to know that things can go live and with minimal trouble, will need to use, if not the Chaos Army or Chaos Army's ideas, something very, very similar. I think it will mostly be a focus for performance and DR. I think AI has the ability to learn from where chaos engineering has been done in the past and start to look for nodes that might be more problematic. For instance, if you operate a test consultancy working across projects, you might know certain types of nodes are slightly more susceptible to issues, and we can use AI to bootstrap chaos engineering and the Chaos Army. But I do think yes, it will become mainstream tooling, and I think organizations pushing microservices distributed system will need to adopt it or something very, very similar.
Great. I think I used to get all of these emails from Netflix saying they refunded me 8 cents or whatever anytime something went down, and I haven't had those emails in a long time. And I don't know if it's because of the Chaos Army or they just changed their policy. So I just wanted to run through the last couple of slides here. So here's some references. I believe if you have any others, we could send them out.
Yep.
We'll share these slides online.
So the stuff here, if you want to just learn about AI and testing, you will find there is some content for those of you who want to read more about AI and test. It's not really, you won't find as much. For the people that want to get started with it, the better idea is to understand the AI fundamentals and the data science fundamentals and how we start to apply these toolkits. For more detail on AI and testing, Qualitest will be producing a lot more content on this in the coming months that we can talk about. And you will find it is starting to gain traction on things like tester meetups and testing forums. So keep your eyes peeled there. But for just general theory on AI, how do you get started? There's an awful lot of toolkits out there, and much like an awful lot of things with software, one of the best ways to start is read up on it and try it and see.
Great. And I just wanted to bring up one thing with QA Symphony. So if you're familiar with our Qtest product line, our testing software, we're adding in all kinds of artificial intelligence over the next year. Some of it will be this year, with the goals in mind of helping you save time and money. So maybe intelligent scheduling of your tests, recommending which tests to run if you already have the test. So these are things that are kind of a easy, safe introduction to artificial intelligence. We're not just going to say stop running your tests. You can trust us. But you can start seeing these things regularly in the QA Symphony product. So please go check those out. You'll hear more about them at those conferences I mentioned earlier. So feel free to dial into those to see what's coming up. And so thank you, everyone, for joining.